My dissertation topic is machine learning applied to building information models. So firstly, here we'll look at the general concept of the data in construction industry and the main concept of digitalization construction 4. Even though no unified definition of construction 4 exists, is mostly accepted as a paradigm of digitalization focusing on BIM and common data environment. It also includes the use of digital tools such as big data, artificial intelligence, Internet of Things, and many more. And this digitalization process also brings some challenges to the industry. Among the identified challenges, there are a version of novelties, the data quality that includes the technical problems with the data structure and the data size. Also, fragmentation is one of the most important challenges in construction industry. It has several dimensions. These two, learning and interoperability, these are interconnected with the fragmentation and with each other. The lack of interoperability causes a delay in the learning process. To look through from the learning process, I want to show this chart, which looks into the framework of data to wisdom in 2 dimensions of concept and understanding, and in the scope of the time from past to the future. I will shortly explain these 4 concepts. So data in this chart is represented as doing research and gathering parts together. Then it goes to the information where these parts are connected, and from researching we are going to observing and doing. And now the main concept is go to the information through the learning to the knowledge, which is the formation of whole and interaction with the information obtained. And for the future concept is to obtain wisdom with joining all these wholes and reflecting from this knowledge. To achieve this learning process and to be able machine to learn, as a tool, I want to introduce space syntax theory, which is a conventional tool for analyzing urban and architectural design data. It also enables the use of computational tools in such analysis, such as particular software or scripting language. In our case, in case of our dissertation, it will help to convert the raw data from BIM model to machine readable format, and will be used as an intermediating language. So I will be introducing one concept of space syntax theory, which is the convex map. It is the simplified representation of the architectural space. Here, the numbered are the rooms, and these are connections between them. And more simplified variation is the connectivity graph, where the nodes are representing the spaces and edges representing the doors between them. With introducing BIM modeling, industry start to deal with the big amount of the data. So to implement knowledge from this, the data science technique should be implemented. Particularly in this dissertation, we was looking to machine learning approach and deep learning approach in particular, because deep learning is the kind of imitation of the human brain, and it can understand some patterns from the non-structured data, which are not obvious. So literature review was also an important part of this dissertation. Here we can see some examples. This is an example of layout generation and recognition from the image. Where the neural network application were used. It is a similar approach of automatic generation of layout from the footprint of the building as an input. One more similar approach here, also connectivity graph were implemented as an additional input. Then the implementation of generative adversarial networks, which are part of neural network, started to implement 3D data. And here you can see some automatic generated models. Some researchers start to use the data from BIM models. Here, the Revit API was used to extract the data connectivity from the model. And the last one, it's graph neural network in use of 3D models. And here you can see automatic generation of some models. So in the overview of this literature review, it was revealed that not a lot of researchers look to the direct data implementation from BIM models. And that's why the case study was proposed. And applied. The main purpose of the case study was to use BIM model data, define a methodology for extracting machine-readable data from BIM model, test the implementation of machine learning algorithm in that data. So the methodology is to define the data set, define the export format and method, format the data, and implement the algorithm. In that case, the Autodesk Revit software and Dynamo language were used for model generation, and for the algorithm generation, Google Colab environment with Python programming language were introduced. Firstly, the data set that consists of 3, 4, and 5 room models were generated synthetically. Then here you can see the representation of this layout as a graph. Here each layout has identification and each room has identification. But for this, make the data as a graph is not enough for the machine. So to make it machine readable, the connectivity matrix was created in Google Colab from the extracted CSV files from Revit schedules. Here you can see ones are representation of the space where they have connections, and this is visualization of some graphs obtained. Each graph is one layout. So as a result, the machine learning algorithm was trained, and around accuracy level of prediction was identified at 25. The desired prediction level of should be around 70%. So some reasons for that were identified. Firstly, it's the data amount, because with increasing of data amount, the prediction results are increasing. The secondly is the data quality. In my case, the data as an input were synthetically generated, and it significantly lowers the quality. Also, additional classifications. In the case study, only the connections were used, but there can be added some additional classification that also improve the data quality. So conclusions from that, in general, the implementation of BIM data is considered successful. The machine was able to read the graph data and run the algorithm. We achieved a faster processing time of the algorithm and data collection, as we don't use Revit IP, and the whole framework includes is working on the CSV files from simple schedules extracted from the Revit. So. In conclusion, it was proposed some questions as a guidelines for future case studies that can be developed based on this research. So firstly, these questions can be answered for future research. So firstly is there enough BIM model data? What is the quality of the data and the form of the data format? What is the problem that can be solved in the industry? What is the relevance of the data to that problem? Which algorithm should be implemented for this particular solution? how can be available data to be shaped to train this particular algorithm, and how will obtained results impact the problem addressed. And additionally, some improvements and further developments were suggested based on the proposed workflow. So firstly, it's interoperability, because using the data from IFC format will create a standardized and open source workflow. Then we will not be limited to any native software, and the work can be adapted with different disciplines in the industry. Secondly, the space syntax framework. The results of this study consider the usage of space syntax also successful, but we also want to propose further implementation of different types of space syntax analysis, such as visibility, iso-waste, and so on. Additionally, automation can be one of important parts. Definition of automatic data extraction workflow, because in that case we can obtain up-to-date data automatically, and this will improve the learning results. Other machine learning algorithms also can be applied to discuss the data quality and precision quality obtained by different type of machine learning algorithm. And lastly, it's the practical applications. And this framework can be used for the practical applications that can include clash detection or model information checking in the industry. So that's all. Thank you for the listening.